Hi, my name is Chris, and this is my YouTube channel. My goal with this channel is to describe some real-world networking using EVE-NG. And to do that, I've set up a machine, a Dell T5600 with 128 gigs of RAM and a 16-core Intel Xeon E5 2670. It's a dual-socket machine. So it has some power. It's pretty good. And it's so if you're not familiar with EVE-NG, there's a lot of YouTube videos on how to set up EVE-NG. I'm running EVE-NG Professional on here, and I just bought it recently. It's worth the price. It was about $130, I think, for a year subscription. But it seems like it's really pretty good. I think it's pretty solid. So what I'm going to work with here is the environment that you see on the screen. So this is the internet up here in the top part with all of the different ASs. That's going to simulate the internet. Anything above R1 and R2 are going to be the internet circuits. So this site will be connected by two internet circuits, right? You can see R1 connected to ISP1, R2 connected to ISP2, and then there's also a machine out here, a Docker machine. Let's open that up. So on this Docker machine, so this is a machine out on the internet, and we can see the IP address for this one is on the 25.10.10/30. So it's out there right here, 25.10.10/30, and it's connected to SP3. And all of these routers out here, all these internet routers are running BGP. So this is running, so let me show you, enable that. Show IP interface brief. Let's get a lay of the land. So gig 00 is on the 14. Right here, you can see that. Gig 01 is on the 24, and gig 02 is right here, and that's where that Docker container is. So nice thing about EVE-NG, with the Docker containers, you can run almost anything and be able to run like a browser and do some testing, make sure everything's working. Okay, so that's SP3. So let's look at the config on SP3 for BGP. So show run section BGP. Okay, so this is in BGP AS500. Network, we're advertising the 24 and the 25 networks into BGP. So show IP BGP. And here we see what's being advertised. Here we see the table on this router right here. And we're getting the 111 network. So that's being advertised from SP1. And there's two routes to that. So it's either the 24 going through 400 to 300 to 100. So it actually looks like that loopback is on ISP1. Let's make sure. Let's check that. Let's go over to ISP1. Enable, show IP interface brief. Yeah, okay, so the loopback is here. So what we can see here is that this loopback is being advertised 400, 300, 100, or 300, 100. So 400, 300, 100, or 300, 100. And you can see what gets installed in the routing table is going to be the shorter AS path of 300 to 100. Okay, let's take a look. So let's take a look at AS 400. So AS 400 is similarly configured with BGP. So these are all just BGP routes. Show run section BGP. And you can see this is not actually advertising anything because we don't see the network command under the BGP process. Let's take a look back here and do a show. So we're on SP3 right now. Show IP route. And here you see that the 1.1.1, which is on ISP1, is being advertised. And you can also see the 65.10.10. So 65.10.10 is going to be the route or the address space that the on-prem is going to advertise out to the internet. So R1 and R2 are both going to be advertising that out, and that's why we see this. And we should see, if we look on show BGP, show IP BGP, we can see there's two paths to 65.10.10, and they're through AS 400, 200, 23,000. So let's see where that is. 400, 200, and then 23,000, which would be the AS in here. This is the AS owned by the customer. So this is the customer of these ISPs. So they own that 23,000. And you can see here that the path would take you right into this to R2. So that's what we're preferring R2. The other path is 300, 100, and then you see the AS path 23,000 twice. That's because we're doing AS path prepending because we want to engineer the traffic to go into one of these two. And I'll show you that in a second. Okay, so that's basically the internet design of this to simulate really the internet and the BGP process in the internet and how we're going to interact from the on-prem systems. So we have two routers, one connected to ISP1, one connected to ISP2. Let's open those up. Let's take a look at R1. So what we're going to do is we're going to enable. Nope, we're not going to do that. We now have to wait. Let's open up R2 while we wait. Let's see, Control-Shift-6. Not killing it. Okay. Let's just wait for that. Okay, we'll open up R2. Enable. Okay, so here's R1. Enable show run. Let's do a show run on that. So gig 00 of R1 is going back to a switch, while gig 01 is going to the internet. So gig 01 the IP address is going to be 12.10.10. So that's the IP address space between on-prem and the internet service provider. So that's what they've given us. So let's look at the BGP setup. So this is router BGP 23,000. So we're in AS 23,000. The network that we're advertising right there is the 65.10.10/24. And our neighbor is the 12.10.10 remote AS 100. And we also have a route map BGP out. So that is where we're going to do the prepending. So route map BGP permit 10, set AS path prepend 23,000. And that is why when we look at SP3 right here, we see this extra 23,000. And it's also why it is preferring, the path that's being preferred is the opposite direction, the 400, 200, and then R2. So any traffic coming from the internet is going to prefer R2. It's going to go from over to here to our AS400, then to AS200, and then into R2. Okay, so that is the inbound traffic. You can see that R2. Let's look at that. So right now, what R2 is doing, it's connected. There's the 22.10.10.50, and its BGP neighbor is going to be 22.10.10.49 with the remote AS of 200. And again, we are advertising that same network out that router. And you can see we don't have any prepending, so it's just going to be the regular path without an extra one. And that's what we see on SP3, that it's only the one path. And that's what we're traffic engineering here to make the traffic that comes from the internet come in R2. And that's our goal there. That's what we wanted to design. And we can change that if we want. We can take away that route map on R1, and that will make it the default. So the default configuration with BGP would be for the lowest router ID. And the router ID is going to be the outgoing interface, the optimal outgoing interface, which would be the 12.10.10.50 or the 22.10.10.50. So it's going to choose R1 by default because it's a lower router ID. Okay. So that is the BGP setup. Now let's look at the ASA. Before we do that though, let's look at this switch. So this switch is just a layer 2 switch. That's all it is. It is just connecting all of these, the routers 1 and 2, to the ASAs, to the pair of ASAs. And what it allows is us to have a VLAN in here, all just layer 2, just a VLAN defined in here in this switch. And for high availability, what we'd want to do is have a stack, a switch stack here, a 3850 switch stack or a Catalyst 9200 switch stack, either one really, and have that switch stack so that we just have a VLAN that's shared among these 4 devices. Okay, so let's open up the ASA. And okay, let's Let's take a look at what we've got here. So show interface IP brief. So you can see it's from using a router, you do a show IP interface brief. For the ASA, it's a show interface IP brief. And so gig 00, that is going to be right here. Gig 00 of the ASA is our outside interface. Gig 01, that's our inside interface, 10.150.254.2. And gig 02 is a DMZ interface, which right now is down because we don't have anything connected to a DMZ. Future videos, we will add that DMZ interface and create some DMZ web servers to demonstrate the connectivity into the web server through the ASA. So right now, that's what we have. We just have 00, 01, 06 is going to be the failover interface. So these are configured in Active-Standby. So let's do a show failover. And you can see this host is our primary, active. And the secondary one is in standby and is ready. So everything looks good there. Let's take a look at the config, show run. So here we can see gig 00 is the outside, like I said, 65.10.10.4. So this is on the subnet that we're advertising, 65.10.10.4. And the standby 65.10.10.5. So 10.10.4 is what we're going to be using on the outside, right? And on the inside, we've got 10.150.254.2. So that's a .2. The .1 is going to be the 10.150.254.1 is on the core switch. All right. So again, here is another layer 2 switch for the ASA to the core. This really could be the same layer 2 stack if you'd want to do that. There may be some thoughts of issues with security doing that. If you've got the money, you may want to separate those stacks, but really you could just do the same stack and just carve out another VLAN and plug these all in to the same switches. That's certainly a possibility. All right, so we have that, and then we have the core switches, which are Nexus 9Ks. Let's see if there's anything else we want to look at for the firewalls. We've got the failover config right here. We've also got, we have it set up for NAT. Let's do that again. Let's go through. We got the interfaces. We have an ACL that allows ICMP, allows ping just for testing. Object network. We have some objects here. Failover I showed you. Route outside. So we have a route to the outside, which is using 65.10.10.1, which was on R1 and R2. So this is the outbound traffic is going to use 65.10.10.1. And that is, let's look at R1. That's set up as an HSRP show run. So here you see 65.10.10.1 is the HSRP address shared between R1 and R2. So that is how traffic is routed outside. So it's always going to hit this HSRP1, which the active is R1 right now. Let's show that. Show standby brief. And here you can see gig 00 active, local one's active, standby is 10.3, virtual IP 65.10.10.1. So that's where we're routing everything outside. And the route inside is routing all the 1050/16 to 10.150.254.1. So 10.150.254.1 is on the core switch. So that's going to be on the core switch. Let's open up the core switch 1. Here we go. Admin. Let's go in there. Show run. So on the core, we have the VLANs. We have VLAN 15, 254, 255. 254 is the one that is on this segment, this VLAN here, that connects the core to the ASA. And then inside, we're going to have multiple VLANs, as many VLANs really as you want on this core switch. And interface VLAN 5, that will be the management VLAN. 15 is going to be production servers. VLAN 254, we already know what that is. And there's that IP 10.150.254.1. So that is where that ASA, active standby pair, is going to route all the inside traffic for 10.150. So anything coming in 10.150 is going to go right there. Let's see, anything else? So I don't think there's anything right now that we want to talk about on the ASA. So let's go back into the core. Let's take a look at the core. So the core also has some VPC, virtual port channel configuration, which we're not going to get into here. Let's see, show VPC brief. So there you can see that VPC configuration is set up between the two Nexus 9Ks. I think that'll be a future video. Talk about VPCs with the Nexus. Okay, so we have show VLAN. So we have some VLAN 15, which is going to be our production server, and that's the only one we're really going to use. Right here, you can see this Docker is connected to VLAN 15. So all these other VLANs, 17, 18, 19, they're for future testing. We don't have to really worry about them at this time. Let's do a show IP route. So the core switch has a static route to 10.150.254.2. So it's sending everything out there to that. And that, again, if you recall, is the Internet ASA. Let's take a look here. Show interface IP brief. And there it is. So that's gig 01. So that's where everything's going to be routed out to Internet ASA 1. This pair, really, it's a active standby pair. So right there you can see that. Okay, and then what we have is a switch, a trunk down to this access layer switch. And this access layer switch would be a stack, most likely, of 3850s, stack of Catalyst 9300s, most likely today. That's what you would put in. And it's connected to this Docker container. So let's open up the Docker container. And what we want to do right now is, so let's take a look at we want to look at the IP address, IP header. So here's the IP address, 10.150.15.10. And that, you can see that's the VLAN 15. So let's confirm that it can connect, it can ping its gateway. And it can. So it can ping its gateway, so that's good. Next, what we want to do is, let's see if we can ping 10.150.254.2. So that is the ASA inside interface. We can. So we've got connectivity to there. So at this point, let's ping the ISP1 loopback. Let's go on to here, and I'll show you that there's a loopback on there. We saw it earlier. Show IP interface brief. And there you can see the loopback 1.1.1. So we're going to ping from this Docker. It's going to go to the switch, to the core, to the ASA, to the switch, to R1, and out to ISP1. That's what the path it should take. So let's do a ping, not on there. Let's do a ping on here, on this Docker. Ping 1.1.1.1. Okay, so there you can see it is hitting the loopback of ISP1. So now let's make sure we have end-to-end reachability. Let's click the Docker. So this Docker is the one down here. Let's minimize some of these other windows. And this Docker is the one up here. Okay, so you see 25.10.10.49. Let's make sure we can ping that. Ping 25.10.10.49. And there we have connectivity out to, from this Docker to this Docker, hitting this ASA, getting natted, and coming back. So we have full reachability to everything. And I think that's about all I wanted to do today. So I'd like to thank everyone who watched this, and let me know what else you want to see. Any ideas, thoughts? I appreciate it. Thank you.